Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will explain the object behavior modeling, and I think there are two models for explaining the object behavior, which are use case diagram and sequence diagram. And I think I will cover the sequence diagram in next video. Okay, when we model the behavior of object, we need to show the methods or the operations that are assigned to that object. In other words, we need to show or model what objects can do or can trigger actions or methods. Use case diagram, we use it to represent what the functions or features that can be executed by given object, and the sequence diagram, it will take each functions and shows what the are actions is gonna be run in order to get complete execution for a specific use case. For example, if we have like a function such as login, this is gonna be represented as use case diagram, and we need to explain in details what the procedures or what are the actions that are involved in order to perform a login. This can be modeled by sequence diagram. Use case diagram. Use case diagram, it's used to represent the functional requirements, the feature of any given system. We use the use case diagram to identify the type of interaction. We have multi-types. The actors involved, which means here the rules, and the direction associated with the interaction between actor and use cases, and between use cases and actors as well. As I said, we use case diagram to model the functions and how rules interact with them, and to provide a high-level view of the system. What does it mean here? It means we can use the use case diagram to show in just high abstract view what are the functional requirements and how these functional requirements are assigned to the objects. And I think it's useful when presenting to managers or stakeholders, because the diagram simply is enough to be understood by all kind of stakeholders. We can use this diagram to highlight rules and functionality without going deep into inner working of the system, which means we just give and represent the functional requirements and features. Use case diagram components. Use case diagrams mainly consist of 4 objects, which are actor, use case, the system, and the package. I think we focus here on the actor and use case mainly, and the system and the packages we use it especially when the system is huge. But those 4 objects are the main components of the use case diagram. This is an actor. Actor in the use case diagram represent any entity that perform a role, which could be a person, organization, or external system. And the symbol is just like a skeleton as you can see here. The symbol is like skeleton. Use case here represent a feature, a function requirement, or activity or action within the system. And the symbol is like an oval, and we name it with the function. Just we draw the oval and rename it with the function or activity. It's a system, and as I said earlier, it's optional. We use it in order just to define the scope of the use case, and it's like a rectangle, and it's used when the system is very large. And I think we use it to group the related group subsystems together and so on. It's optional like in system. It's used in the complex diagram, and we use it to group the related use cases. In the use case diagram, there are 5 types of relationships, which are associations. The associations is going to be between an actor and a use case. Each actor should be associated with at least one use case, and each use case should be associated with an actor as well. A generalization of an actor and a generalization of a use case. Extend and include relationships. The extend relationships and include relationships are between 2 use cases, and I will explain it in more details. Associations. The association is gonna between a use case and an actor. We use it to represent how specific actor is associated with a use case, and an actor must be associated with at least one use case, which means we can't draw or use an actor without associating a use case to it. And it could be an actor associated with multiple use cases, as you can see in this diagram. Like the customer, this is an actor, is associated with 2 use cases, open account and deposit funds, where the bank employee is associated with one use case called open account. And you can see here multiple actors can be associated with a single use case simply. This is an association. Here we can see, like this diagram, you can see we have 2 actors and 2 use cases, the open account and deposit funds. The customer can open account and can deposit funds, whereas the bank employee just can open the account. Generalization. A generalization is like inheritance, and I think we explained it in the previous video. Generalization of actor means that one actor can inherit the role of another actor. Let's say the child inherits all the use cases of the parent. The child have one or more use cases that are specific to that role. Okay, let's explain it in this diagram. You can see here we have a customer actor and we have an RFC customer. An FRC inherits all the use cases that are associated with the customer. In other words, I can say that an RFC customer can convert currency and open account and deposit funds, where the customer just can open account and deposit fund. The bank employee can just open account. This is the generalization. between actors. We have extend relationships between two use cases. The extends relationship is just occurred between use cases. The extends means optional, which means if one of these cases performed, the extended one, it could be performed or not. It's optional. As the name implies, it extends the base use case and adds more functionality to the system. Here are the few things to consider when using the extended relationships. Let's give you an example. If we have a use case name login, we can extend another use case to change the password. Changing the password use case is optional, which means if we log in, we don't need to change the password. But if we need to change the password, we need to log in. The extending use case is dependent on the extended base use case. The extended use case is usually optional, and this is the main important thing. It's optional, it's not compulsory, and can be triggered conditionally. When we have extended use case, it should be triggered based on condition. The extended base use case must be meaningful on its own, which means it should be independent and must not rely on the behavior of the extending use case. Example. As you can see, the calculate bonus use case extends deposit funds. What does it mean? It means the calculate bonus is optional and it is executed based on that condition, which is amount over 10,000 or age over 55, which means when the customer deposits a funds, the bonus is going to be calculated if the amount over 10,000 or the age over 55. In other words, when the customer deposits fund, it's optional to calculate a bonus, which means if the calculate bonus use case, it could be executed or not. The include relationship. The include relationship, it's mandatory. It's not an optional like the extend use case, and we use it when common actions across multiple use cases are reused, and we use in order to break down the complex behavior and to assign it into more than one use case. The main thing here is that the include relationship, it's mandatory, it's compulsory, and it's not optional, and the base use case is incomplete without the included use case. This is an example, shows the include use case relationship. As you can see, there's an include relationship between deposit fund and update balance. What does it mean? It means when the customer deposits a fund, the update balance should be executed. It's not like the calculate bonus. The calculate bonus is 16, which means there's a condition should be assigned to be executed. Here, the amount over 10,000 or the age over 55. But if the customer deposit less than 10,000 and the age is below than 55, the calculate bonus will not be executed, but the update balance should be executed when the deposit funds is triggered. Same to the withdraw funds use case. The withdraw fund, when the customer withdraw funds, the update balance should be executed. That means it's mandatory. It's not an optional. Which means the withdraw funds, it is a base use case, will not be complete if the update balance is not executed along with it. Generalization of use case, we use generalization when there's like a common behavior between two use cases and more. It's like the generalization between the classes. For example, if there's like a use case called pay bills, it can be pay by credit card or pay by bank balance or pay by checks or whatsoever. And this slide gives some guidelines when we creating use case diagram. The first thing, give a meaningful business relevant names for actors. For example, it means like we need to give the actor a meaningful name. Primary actor should be to the left side of the diagram, because we read it like from left to right. Actors, models, rules, not positions. This is a good one. We need here to represent the rules of the actors, not the positions. External systems are actors. Actors do not interact with other actors, which means there is no association with within actors. Place inheriting actors below the parent actor. It's like the inheritance class diagram. Examples. As you can see, the customer and the suppliers, it's an association. There's no association between actors. And the project manager with the great employee, it's like a position here, a project manager, the position, but the rules, it's the assessor. It is a good choice to name it rather than project manager. Example of simple class diagram, use case diagram. You can see one actor and one use case. Like a good example of use case diagram for library system. As you can see here, we have three actors: library user, suppliers, and library staff. And we have four use cases: article search, article printing, user administration, and catalog service. As you can, the library user can perform three functions, or let's say there are three use cases assigned or associated with the library user actor, which are article search, article printing, and user administration. The supplier actor is associated with one use case called catalog service, and the library staff actor is associated with two use cases: user administration and catalog service. Multi-threading versus use cases. I think we use, in some cases, it might be a use case consists from one scenario, which means this use case or this function could be executed or could be carried by different scenario, more than one scenario. For example, we use in thread, but don't focus on that. This is an example of another use case for the ATM use case diagram. As you can see here, we have four actors: customer, maintenance, and stocker, and the bank. You can see the system. This means the bank, or it means it's an external system interact with the ATM system. We have here 6 use cases. What does it mean? Like, we have 6 requirements, 6 features, which are withdraw cash, deposit funds, check balance, transfer funds, perform routine maintenance, and fill ATM with the cash. And you can see here, at least there's, for each actor, there is at least one use case associated with it. This slide differentiate between the extend and include relationship, and I explained it previous. The main difference is that extend is optional, it's not compulsory. The include is mandatory, it's compulsory. This is the main difference. And for use cases, there are many templates to represent the use case, or let's say the use case scenario. This is like one template. It consists from the name. You can give the name of the use case, such as, for example, login, logout, add a course, ID, which is the identification unique to each use case, 1, 2, 3, 4. Description, this is like, it's gonna be a brief statement about the requirements or the use case. The actors means here we need to identify who gonna interact with the system to accomplish the task, and what are the benefits for the organizational, and how this is gonna be used, the frequency of use, the triggers, preconditions, post conditions, main course, alternative courses, and exceptions. I think this is a long table, let's say, but I think the most thing here, the name, the actors, the preconditions, the post condition, and main course. What does it mean, preconditions here? The preconditions, we need to state and specify what the state should be in for the system before executing the use case. For example, the login use case. The precondition for the login use case should be the user has an active account, which means we can't log in without an active account for the user. The post condition means a state that the system must be, or in a condition that must be met after the use case is completed successfully. Let's say if we need to add a course. After adding the course, the post condition will be the course has been added. The main course, here we call it the basic path, or the most common path of interaction between the user and the system, which means the steps that should be executed in order to perform the use case. Alternative courses, which means might be we can do this use case with different scenario or with different path, alternative path. The exceptions here means what can go wrong. For example, for the login, it might be invalid username or password. This is wrong. A few use case for one of projects for our students, IoT. The use case here, the use case name, measuring the pressure on the pillow. This is to measure the pressure on the pillow. You can see the active sensor, description, and so on. This is that you can read it. Example.